Okay, so let's conclude this nice report from CEEW, the Council on Energy, Environment and Water. What was it? CEEW, there are three E's, right? So, Center for Energy, Environment and Water. There we go. So I should remember it, but so many acronyms in my head, and I'm old now, you don't realize. So I keep forgetting things. So I love this report. This is very nice. As we said, lots of localized analysis, and these conclusions build on how to use this, especially in terms of action at local level. All global warming is local. All adaptation has to be local, location specific. All climate risks are location specific, and you need information at hyper local scales. And all sustainability will also be local, and it has to add up to global sustainability. All local adaptations have to add up to global resilience. Your system is only as resilient as the weakest link in the system, right? So mapping monsoon performance at more localized level based on our findings, considering the evolving complex trends such as high month-to-month variability and increasing occurrence of wet extremes, localized decision making is crucial for building resilience against monsoon variability. Presently, IMD provides monsoon information at country, zonal, state, meteorological subdivision and district scales, which is based on existing observation stations. However, this network lacks the density needed to map the monsoon at a more granular administrative level like tehsils that we mentioned. Therefore, we utilized reanalysis data from IMDAA to map monsoon variability for all tehsils in India for both JJAS and OND seasons. That's also important. We tend to have a tunnel vision on summer monsoon and not worry so much about the winter monsoon or the northeast monsoon. We have provided the coefficient of variation and long period average for all tehsils considered in this study in the annexure 1, which I didn't go into, following the WMO and IMD guidelines. Local level decision makers should use these metrics for analyzing local level monsoon performance. This will provide comprehensive actionable insights and enhancing disaster preparedness as well as response. So the IMDAA I think comes at 12-kilometer resolution, which is, let's say, good enough to do things at the tehsil level, but reanalysis is a combination of a model and data. As you increase the data, even for the same resolution of the model, you will increase the past history of the climate you are reconstructing. If you don't know what reanalysis is, you can follow up on other podcasts I have under climate modeling and so on. And basically, it is taking a model, taking GAPI data, and combining them to produce a dynamically interpolated gridded data for the past, which is done, which is done under IMDAA, and this analysis is using that. So improving data coverage will only improve the reanalysis itself, and hence the accuracy of all the analysis further at tehsil level. Development of district level climate action plans incorporating tehsil level climate risk assessments in line with the MOEFCC's 2019 directive. All Indian states and UTs are revising their state action plans on climate change, up to 2030. So this Ministry of Environment, Forest and Climate Change. While the current plans focus on district level climate risk analysis, our findings reveal availability of tehsil level climate information. We recommend developing district level climate action plans, integrating this information with the socioeconomic and sector-specific data for detailed climate risk assessments in critical sectors like agriculture, water, and energy. And just to add, risk as defined by IPCC and others is a multiplier of hazards, vulnerability, exposure, and now response as well. So risk mapping is a critical exercise, and the scale, district level, is a good start. Eventually you want to even go down to tehsil level and village level, urban level, and so on. The global goal on adaptation requires updated climate risks assessments by 2030. However, current state action plans on climate change rely on prolonged climate projections up to 2050 and 2100 for adaptation strategies for the next decade. Hence, prioritizing short-term projections, especially with the advanced global weather prediction models at a 12-kilometer resolution as outlined in the Ministry of Earth Sciences, Atmosphere and Climate Research Modeling, Observing Systems and Services across. That's a cute acronym, right? Atmosphere and Climate Research Modeling, Observing Systems and Services scheme is crucial further to make this climate information more accessible for diverse range of stakeholders. Collaboration among research institutions, meteorological agencies, and civil society is key. Drawing inspiration from global best practices like California's CalAdapt platform for tailored climate action plans aligning with local needs. The scales. Nearly 48% of tehsils in India saw increased rainfall in October in the past decade. The map we already saw, so October for each region. So southwest monsoon is being altered with its onset and withdrawal being earlier and delayed, or later and delayed, and so on. So you are squeezing the length of the rainy season in various ways. You are changing the number of rainy days, and hence heavy and very heavy rainfall events and so on, as we saw. So here, all India average JJS rainfall showing a slightly increasing trend at the rate of 3 millimeters per year, which is not statistically significant. So total JJS rainfall and a linear trend. Lots of discussions on the trends in the monsoon, and my point would be, if you pay close attention, there is decadal, multi-decadal variability in the time series, and trends have to be very carefully determined. Better to call them secular trends, which means they are occurring in the periods, in the sense that global warming, local amplifiers, and so on are modulating the decadal, multi-decadal time scale. And this is critical to understand if there is an intrinsic decadal time scale, because that means you will have ups and downs in the low frequency monsoon amounts, and that could be critical if you can make decadal prediction in terms of planning. So you have local risks, district action plans, and then state action plans, national commitments to NDCs and so on, and all the goals for helping the farmers and other sectors. But if you have decadal horizon information, everything will benefit, right? Finally, investing in automatic weather stations and community-based recordings to capture rainfall variabilities at a hyper-local level. Our analysis highlights diverse monsoon patterns at the tehsil level, emphasizing the need for hyperlocal climate adaptation strategies. The current most defined long-term observational rainfall data available at a spatial resolution of 25 kilometers lacks the granularity required for precise climate models and local action plans. Okay, so historically we have very nice long data set which has been used to make so many new findings, process understandings, data assimilation, reanalysis, everything. Now what do we want in the next 5 years, 10 years, 20 years? Alternative sources such as the autonomous weather stations and citizen science can help in expanding the network of observation stations. Initiatives such as the National Weather Information Network and Data System So wins and community efforts such as school students in Kerala recording micro weather data offer promising avenues to enhance the assessment of microclimatic rainfall variations and inform effective local strategies which should be scaled up. You have to go, local action building up to national level. Climate resilient, weather ready, and so on are all nice words, but without having such micro level, hyper local level information, data, and then downscaling with AI and so on for the last scale, for the last mile, to bring information to farmers, to water resource managers, for transportation managers, energy producers, and what do you have? Health, buildings. It's amazing what you can do if you start to build data network. Now, if we want to hit net zero by 2070, we have to be on a pathway by 2030. That will require that we do this correctly and have a risk map so that every time you get knocked off from your pathway to net zero, resilience means bringing the system back towards net zero and sustainable development. That can only happen with hyper-local risk information, protection for everybody, adaptation for everybody, water security, food security, energy security, health security, and national security, because the vulnerabilities of all our neighbors are our vulnerabilities as well, as we already know from the Rohingya effects and so on and so forth. Okay, so this is a nice report, provides some really good platform to make some points, which they do. I've added my own little opinion to these things, but follow up with the report and the nice references, and follow up with further analysis, and do your own thing about how to enhance data. Okay, see you in the next topic.